Today we are going to be talking about hot patching, zero-day attacks, automation, and configurable layer 2 learning. Um, Faster upgrades and hot patching is something that is absolutely required in today's networking world. Basically, when you have to really upgrade because you are getting attacked or you have to change a security policy or anything of that matter, you cannot be taking days to actually do all of these updates and patches. Additionally, don't want to bring down the network either in order to apply this patch or the ACL that is necessary in order to make this zero-day attack go away. So Faucet SDN controller enables you to do that, and we will take a look at that. And there is also another aspect of how you can provide greater control of layer 2 by eliminating or defeating rogue DHCP servers and broadcast storms and that kind of stuff. So we will also take a look at how you can actually do that. And a simple use case would be, hey, you're connected to a port on the switch, and this machine is actually asking for an IP address from the DHCP server. And what you would want to make sure is that once that IP address is given to that host, you want to make sure that the connection is assigned to that MAC ID and nobody else. That means, how do you enforce those policies? So in order, without having to write all the custom scripts and everything, the Faucet SDN controller can actually enable you to do that in very simplistic terms, in programmatic terms, and in automatic terms. So with that said, what we really do is that when you connect the host to the OpenFlow switch and Faucet managing that OpenFlow switch, we basically make sure that the DHCP request that is actually being presented to the SDN controller, and we actually capture the MAC ID and the corresponding IP address that was actually assigned to it. So if there is actually a link down event or a change, that means somebody else takes care of that, or somebody else connects another PC to it with that same IP address, and because the MAC ID is not the same, you can basically say, hey, you are not the guy who's actually connected to this, and then we can actually eliminate those kinds of threats. So that's another way of actually using the SDN controller, and you can eliminate zero-day attacks too. The other cool part of it is that you can actually do all the automation of the ACLs and everything through scripts. This is basically in an YAML file, which is basically a text file, which we will take a look at it, and uh, you don't have to do all kinds of magic in order to make all of these things work. So with that said, let us take a look at at a configuration file that is in play. What we are showing here is a Faucet YAML file, which is located in etc rev faucet directory for the controller on the controller machine. And then you have three components that I wanted to bring your attention to. One is basically the version information right here, which says this is in version 2. You have the config file version format, and then you have VLANs that are there, and you can basically say in this VLAN you have maximum of 3 hosts that can be connected on this VLAN, nothing more. So that's one way of actually doing another ACL out here, but we'll not go into that in more detail right now. Then you also have the multiple data paths that are being managed by this controller. Okay, with that said, let us go and take a look at that. So as you can see, I'm in etc rev faucet. I can do faucet.yaml. Okay, go up. Okay, this is a little bit more information. Let's do this. I am going to copy. So I have created a few uh, uh, files out here to make my life a lot more simpler. So here is what I'm going to do. First one, I'm going to I'm going to take this unicast flood, which is not necessary at this point in time. We will come back to that. So we will do this. And now that I updated this YAML file, um, here is a simple, I have a simple script to restart the controller. Um, okay, it's extremely simple. So I'm going to just run that script to restart the controller. Okay, and then let's go look at it. Okay, so everything is working. So as you can see in this YAML file, I actually don't have any learning or whatever it is, but I have the things that I talked about in terms of the version information, okay, and the VLANs and the data paths that I'm actually managing. Okay, so now let us say that I make the change again to the faucet.yaml file, and now this time I basically enable flooding, for example, okay, which we can see. Okay, we actually do two things out here. We are trying to override the we are trying to override the layer 2 learning methodology. We are adding unicast flood, okay, on this VLAN, and then by making it into false, normally true is the default mechanism for any switch in the world. Okay, so basically it's going to broadcast all the packets on all the ports, and everybody flood all the ports, and that is how you would actually find out what's there on what port and that kind of stuff. But you can also do without having to broadcast or without having to flood each and every port on the switch. And this becomes a huge problem if you have a 48 port switch or a 72 port switch and that kind of stuff. You don't want to bring down the performance of your switch, and also introduce more security holes because they could be on different VLANs, blah blah blah, all of that stuff. So you would want to make that thing as unicast flat false, wherein you can only learn from the Ethernet broadcast of ARP and or IPv6 neighbor discovery. So whenever you actually send a packet out, we can from that particular port, we can actually find out what the source MAC ID is, and then we can actually do all of that stuff. So what this enables you to do is that first of all, we can do either automatic learning or we can do configurable learning. So with that said, okay, we just enabled the, in the faucet.yaml file, we just enabled unicast flood equal to true on all of these VLANs. Okay, we are going to save it, and then we are going to go back and then restart the controller. And now I'm going to do a tail on the log file. Okay, and basically it is showing me as to what kind of hosts are being learned at this point in time. So I can do a tail minus f for log so it's basically learned all of these so and you can see this is another screenshot from a run that I had. At that point in time, I had connected a Zodiac switch, and you can see as to how those ports are actually getting learned and added and that kind of stuff. Okay, and oh, this also shows you one other thing. You remember that I had shown you in the previous slide the MAC source number 3. So what I did was I connected one more into that VLAN, and it basically said, hey, temporarily banning learning on this VLAN because you have exceeded your quota. So that's another way to control it. So you can actually do all kinds of control and prevent zero-day attacks. And because this is a text file, you can actually automate learning of Macs and that kind of stuff. Oh, one other thing that I wanted to show you, we are actually connected on the overlay OpenFlow network. So while I was doing all of these things, by the way, this is running on Google Slides, so I'm actually connected to the network, okay, and nothing really changed. Everything works seamlessly. So that's the demo, and here are some resources for you to go grab more information on how